So I wanted to go back and look at the screw jack, and I'm going to look at the this for envelope to see if I can 3D print one. All right, we talked about some of the different issues with the design. Thought this would be interesting to look at film material, be able to do some direct editing, and try to analyze clearances if we're going to print this as a possible single piece. What are the implications, and how much do I need to shrink those threads to actually make this functional? Typically, your film material, we're at, oh, now I'm pulling off the 1.75 millimeter. So 2 millimeters is 80 thousandths, and we would need, let's see. There I go, doing math in my head again. I'm going to get myself in trouble. We need enough clearance that that film material can build up at least a couple of layers and be able to dissolve and have clearance. So in the case of this thread, 1/8 of an inch, yeah, we might be able to get there. You know, if not, having to print these as separate parts, what are the strategies there? All right, so don't know quite what we're going to encounter, but let's go through at least the direct editing portion. And at least the first go around would be, what am I going to do with the thread geometry? All right, so if we need clearances, I really need sloppy threads. I need these to be no way that we're getting to a class 3 fit, and we're probably less than a class 1 fit if that exists. All right, so even though these are large square threads, I need to decide, am I going to build to make the modification on the internal threads or on the externals? Or split it across both of them. I think that becomes a little more complicated. Maybe growing this by 15 thousandths, 20 thousandths, and then also shrinking the threads by 15 or 20 thousandths if we're not consistent on that edit. You know, but then again, we're going to probably fail on the first 1 or 2 prints anyway to get these to actually be a moving mechanical fit between 2 plastic parts. All right, so kind of working through the considerations, I think it's going to be more visual or something that we can see a little bit better if I do the externals. So looking at this piece, this is pretty much the orientation that I want for the print. The issue is that I notice is that we have this radius, and we have the first undercut. I may not have to. Now let's go back. Let's see, section view, and we'll go to a right. Okay, pick one. There we go. I may not have to do fill material all the way up to the base of the threads, at least from this angle, that I would have enough on my diameter, and this being fairly small, it would be able to approach. The overhang, I'm not so sure about. This lower overhang, I'm going to have to use fill material. There's no way that this won't collapse. Or if it's not needed for the design, get rid of it. All right, for our first go around for production piece, yeah, it's nice to have that relief, do whatever it does, but on our worst case scenario for the print, if it makes it to this stage, I don't want to find out about the threads necessarily printing half of it, but maybe I can close this up a little bit more, and this overhang, even if this small amount droops as it goes into the thread, that may be acceptable, right? But this bottom, definitely not. So getting rid of some of these, let's go back to the standard view, and my cast iron is a little bit difficult to see, so let's go just to wireframe, or the hidden lines removed. All right, and then as I rotate, it'll show. So a couple of options. The way that I built this in the full revolve has that geometry. For the print, I really don't want to, I don't want to say contaminate. I don't want to modify this past the point of being able to return to it. So if I'm pretty sure that this is going to work out, I will go with my construction geometry strategy. And that didn't quite close off the way that I expected it to. All right, so there did get a little line in there. So my mouse is still acting a little weird. And that becomes horizontal. And then these two become construction lines. All right, now that geometry is gone. But I don't have the ability to turn that on and turn it off. I have to go into the sketch each time and swap those to construction geometry out of construction geometry. So this is leading towards configurations, a use of configurations. I may have a machine configuration. I may have my 3D print configuration. I may have my as cast configuration, because the casting is not going to include those threads. If we decide that we're going to cast these aluminum out of aluminum bodies, or stay with the ductile gray cast iron or whatever, we're not putting those threads in as part of the casting. We may have the through bore to center and be part of the locating and manufacturing process, but those threads don't come with it. All right, so we still have to make those decisions of how much material, how much clearance we're going to need for our manufacturing process. So when we start down the list of the design for manufacture is, wow, we got this really great idea. This is what it's going to look like. I already said that if we were going to CNC this, it's not going to be a 3-axis rotary 20-hour per part machining operation. We need to come up with a CNC part that is either conical and has some kind of a rib relief or something that we can do quick. But that's a whole, that one really leads into a whole nother conversation on that manufacturing. It completely changes the design. So for quick reference, maybe squaring these off so that I have a corner here and that I can get into these angles and these radiuses fairly straightforward, fairly easy. I could see this being a rectangular prism rather than a cylinder, and that would be something that I could hold in a vise, hold in normal work holding, normal fixturing, and not be doing anything crazy special. The base being round, okay, I'm still okay with that, because I would still want to run these threads on a lathe if I could. All right, getting in, opening up that bore, running the square threads. All right, so for the manufacturing, on the manufacturing side of things. All right, so getting into this, getting back on track to my 3D print. Configuration 1, we're starting off with our geometry. So I'm going to add configuration. We're going to be at the top level, not at the default. All right. If I go to any other configuration, then I'm getting a derived configuration. That means that I'm starting to nest those configurations, and I don't recommend you do that. Even after, as long as I'm doing this, I stay away from the derived configurations unless I can come up with a really, really good reason why that family of parts needs a subset of family of parts. All right, so we're going to go with the 3D print as my configuration name, and things that I would want to look at. We're going to stay with all of this geometry, and where I can, I'm going to go with direct editing. So I don't know if let's see, delete face will cooperate here, but I'll try it. I'll try the direct editing before I just create filler geometry. All right, so when I delete a face, we're going to delete and patch or delete and fill. And face 1, face 2, and we'll see what it does. Closes it off. All right, so the patch and fill says that those two faces disappear, whatever the intersecting geometry is, I've got it. And I also have a feature that you would look at and go, delete face, what's that all about? That's not normal. That's not something that's part of this. You know, it's going to stand out as, you know, I did something intentionally for this model. Other things that we can do that we're going to look at for our thread geometry is called a move face. What else did I want to do for the 3D? Like I said, I think that we can probably have it. The filament will find its way up over this arc and be close enough to the geometry that we'll have maybe a minimal amount of droop on that overhang, and then start into the threads. All right, I'm willing to risk it. As far as the top, okay, and then if we're going to stay on size, well, let's go ahead and add. I'm just really having a hard time justifying to myself that that whole shape. So let's go ahead and save, and we'll jump back into our geometry. All right, so 3D printing this one, picking an orientation, probably not laying flat. I mean, it may have the length but all kinds of support material and the helix, and then the hole's not going to quite be cylindrical and some other issues. Printing it up, I could probably go with the fill material up to this stage and then get a little narrower. Problem's going to be is the printer is pushing around on top of this, is that as long as this is, I'm kind of expecting it to fall over. So unless we're going to continue with the fill material at least a little further up the threads, we're not going to get a lot of I'm not going to get a lot of cylindricity out of this shape. And at some point with even a small patch, a decent sized raft and a small patch, I expect that my extruder will catch on one of these pieces of geometry and pull it off of the base and crash the print. All right, so those are my considerations. So I'm I said I'm not sure which way I'm going to print it, but we have to start some way. I could also, and as scary as it sounds, I could also print this without the threads, and then make this a solid fill or nearly solid fill, and try to machine those threads into my 3D printed part. Problem there is that filament, those basically the laminated, where the bonded layers, if I get one of those to unravel with my my threading tool, I'm going to unwind the whole part and snap, we're done. All right, so this rigidity going this way, we're not going to have it. So at some point we may be saying this really isn't a part that we need to 3D print. Doesn't lend itself to it, can't justify it, or is not doesn't have a reasonable chance of success. And that's perfectly legitimate conversation. That being the case, though, we're going to try to 3D print one. So fill material, my considerations, we're going to go back with add configuration. I will pull another 3D print. The naming on the configurations, not so critical, because this is 3D print configuration at item 3 lifting screw. All right, so any addressing, anything in the bill of materials is going to come back to that part. What I'm not sure of is we need to be on the underside. Well, top and out, at least those three. I'm going to go ahead and take the chance and do the interior. So basically all that geometry, I need to shrink it by probably 20 thousandths, half a millimeter, to even get close to having enough clearance for this to print and be able to overcome those limitations. All right, so that being the case, let's see, what's the top one doing? We'll go ahead and include that. What's the worst can do is fail. Move face. So prior to direct editing, we would go into surfaces and offset surfaces, and it was a pretty time-consuming process to account for anodize, account for powder coat, account for thicknesses of, or making something thicker so that we could send it to grind. All right, with the move face, I can say make this 5 thousandths bigger so that my pre-machine, my pre-grind configuration is slightly larger, or my pre-anodize is slightly smaller. Thou or two smaller. If we're holding critical tolerances in the anodize, it has to be part of that tolerance stack up. Our dimension then, we'll go with the, let's see, I'm shrinking it, 0.02. Hey, it didn't crash on me, so I'm calling that good. And since I didn't pay attention to which way it was going, well, it still has to complete, doesn't it? All right, failed to move faces by the specified parameters. I can't really tell on the preview which way it was going. And, oh yeah, was this already in metric? No, it's an inch, 0.020 inches. All right, so let's take at least one of those out, one of the faces. And that grew it bigger, so not. Is it going to let me flip? And that should make it smaller. All right, so the issue may be up here in the corners. And in that case, then I would have to set up and make those dimensions smaller as a function of the swept cut. So let me think through that for a second. All right, so if that's going to fail, then my cut sweep sketch has geometry. Let's go normal 2. And so we're 125 by 125. So shrinking it, I do need to go smaller on the diameter as well as taller on the cut and deeper on the cut. So I'm thinking in reverse. And I'm back to those maximum material condition, least material condition. So we're moving towards least material condition. So let's go to 0.15. 0.15 and rebuild. Darn it. And since I forgot about that, let's undo. Double click on that again, and this time we'll pay attention to the modify, and under modify come over to our configuration group. Right, so you have to go through that process once, forgetting about it, and then it changes the dimension. Then you go, oh, I went back to the default changed too. We go into this configuration group, and it is this configuration only. And as soon as you add the second configuration, we go over to the configuration tab, we add a configuration, this becomes available. You're not going to see it until you have that second configuration. So this configuration gets the value. And chances are, since I already accepted it, I'm going to have to go back and fix the other one anyway. So this configuration, go ahead and accept, and we'll rebuild. All right, so we have a little bit of an issue with our sizing here, but we need to shrink that anyway. And let's see, we have the Knurl. So let's switch back and double check to the default. And sure enough, it stayed. So 125. Now once I've put this configuration, activated this configuration, it's going to stay. All right, it's going to stay checked, and I would have to change it to all configurations if it's that kind of change. All right, so we'll jump back into the 3D print. And the reason that we struggle with configurations is because I have to set up the criteria and get it straight in my mind what is happening in this configuration. What's going to be affected globally throughout the whole part, what's going to be affected in the 3D print versus the machined print versus the cast print, or the machined part, the cast part, etc. All right, so when we go back into this, I should be able to see my revolve. And we removed, where did we remove that material? The cut revolve. All right, so that ended up being a 0.25. That went to a 0.98. So I just took 50 additional thousandths off the diameter, I believe. So this configuration is 9.3. And that changes it all the way, well, at least to that cut. So it was this one. Okay, so what did that one end up being? Because I can't do math then. 9.3. How about the outside, since there's a lip there? Arc length 1.79. So it's got a little elliptical to it. See if we can get an evaluate measure off of it for the cylinder. Area perimeter still didn't quite end up. So why is that a partial? Okay. So subtracted. Okay, math works out. Not sure why I have a lip there. And probably not going to get from the point. Yeah, pretty much because it comes back to the blend. That's the top side of the angle. All right. So, yeah.
So when you just went in and edited the sketch where you had the square,
Mm-hmm.
you changed from 0.12 by 0.15 in each dimension before that.
There we go.
I kind of lost you in that. Was that an alternate way of doing what you did just before then, which was the direct editing?
Because the direct editing failed. It would not allow me to shrink. It would not allow me to put that face interior. I'm making this dimension bigger to take out that material, to remove that material, so that I have the clearances for the print.
Right.
And then it's only in this configuration. So as I switch back and forth in configuration, and that's one of the things that happens quite often is that when I first go into the dimension, it's all configurations. And I don't catch that box on the first go around. And then after I do catch it, I've changed it for all configurations. So if I can quickly undo and get back to its previous state, and then make sure that it's just for that configuration. So the process is to make a change, go through the configurations, double check your change, and one change at a time, so you're not accumulating this really drastic bunch of, wow, what just happened, and none of it makes sense anymore, because we're starting to set up that spider web, and we pull on one string and this unravels, or we pull on that string and that unravels. Then we have to know how to tie those back together.
That makes sense. I think what I had to do before was clicking on direct editing, that part.
Right, and so to delete the face, that's a quick way of, I don't need a hole there. I don't want that hole to be included. So for this, since if I am printing in the vertical geometry, delete face and move face are pretty much the two that I would use. And occasionally move copy bodies comes into the mix. Very rarely the delete keep. But pretty much those three we use regularly, or be prepared to use regularly. So when I delete the face and delete and patch, if I delete and fill, it will leave the circles where they were or where they connected. And other than that, now you see them, now you don't. They're still there, but that delete face said where those cylinders are, I can calculate what this intersecting geometry takes to fill it back in, or to patch it back in. And then when I go back to my other configuration for the default, hopefully the direct editing items get suppressed. They're not participating in the default, and then I will see my geometry again. So this shifts and this shifts back to its previous state. So we're managing, in this case, we're managing those states. We're managing those dimensions based on our design intent for that configuration. That's why even the configurations going through 5-2 through 5-9, it's setting up for configurations is always going to be a little more difficult to get a handle on, get it set up, get it working. But once it's working and doing what it's supposed to, we have an immense time saver. I have one part with 9 or 10 parts embedded in it as configurations. In this case, I'm able to do my what-if scenarios, look at tolerances and clearances for the 3D print or the cast or the machine part, all out of one item rather than creating 3 different assemblies and 3 different sets of parts and 3 different everythings. And then if, worst cases, when we go into the assembly, we're going to pick these configurations, and worst cases, we can mix and match to see which set of tolerances really make the best fit. But that's not the intent, or the end game is to set a 3D print level, a machined level, a cast level, and have those items available to us. And so this piece was actually mild steel in the print, so it'll only get the machine. We wouldn't even make one for the cast. All right. The other item for the 3D print would be as well with this face. We're not going to, whatever we decided, have 20 threads into that geometry. We're not going to print the threads. They're too small. We're not going to have enough resolution to get a usable thread. So that being the case, if I go to this minor diameter, the minor diameter will still be usable, and our geometry, and maybe I would even want to make it a little bit smaller. The danger of making this smaller is if I tell it that there are 3 passes on the wall, I may not have enough to cut 20 thousandths or a pitch of 20 into that thread and maintain the integrity of that wall. Right, so either I have to go back in and say for these segments, this gets 5 passes on the wall, in which case this will probably end up pretty close to solid all the way through. And I have a reasonable chance of taking a tap into this hole and maybe even chasing it with the tap drill, but taking a tap and threading this hole and having it be a mechanically sound or reasonably mechanically sound tapped hole. All right, so I want to be careful before I make any major adjustments to it. All right, so going back to the 3D, and there again, this isn't critical. What I wouldn't do, one of the first pieces that I 3D printed was a vise, and it had the handle coming through. I don't know. I did that hole removal more as an example. I might want it there, but then this isn't really lifting anything, is it? For our purposes, we might lift a couple of books on the desk and see how it operates functional ergonomically, but we're not putting the kinds of loads that we're expecting the cast and the steel part to take. So I could pretty much turn this by hand. We called out a fine knurl. I would have to create that knurl, and do we have enough time to do a knurl? Knurls are another one of those advanced loft or sweep items that it takes a little bit to set up, but you can get a really nice diamond shape in your geometry that then the 3D printer is capable of printing. All right, but if you can't create the geometry, you don't get it. We get this nice cylinder. The other side of, all those little facets are going to take a while to print. So, are we willing to take on the additional print time to get that texture? And then what's the value, at least on the first go around? All right, so I'm just deciding how brave I feel. Okay, why not? So in the 3D print, double check 3D print, and then if I come back over looking up at the part, we're in 3D print display state 1. So the first item is the configuration, second item is the display state. So if I wanted to have this display state, a second display state, usually I'll create one called work in progress. that I can switch back and forth in assemblies. Switch back and forth as I'm building different multi-body parts. We could do one that was transparent, so I can switch between transparent. We've done marketing, product marketing, that we need one in red, one in blue, one in black, and we want to be able to switch between those and render them pretty quickly. So having a display state that takes on the properties of color, transparency, visual properties, as opposed to configurations that take on the size, the numbers of objects in a pattern, those types of things. Right, so that's kind of the split and how we're reading this top part title. All right, so one of the things that we'll need to create this knurl is, I'm going to stay with the I want the deleted face. Where does that actually occur? So that's the tapped hole. We have to have a through hole through at some point, and those are those two. So I'm going to roll back just before the holes, not including the deleted face, mainly because in my history I don't want to tie this knurl geometry to anything parent or child that would cause it to have a problem with the rebuild. I'm going to put this in an order where it makes sense to me. It makes sense to me now. It may not make sense to me later, but right now this looks like a good place to put it before the holes go in. All right, so on the front plane, and double check, front plane is going through the part. I'm going to open up a sketch, maybe, front plane, sketch, and we're going to need one center line. Yeah, let's go ahead and make that a for construction. All right, and then I want another, and my diamond's going to have I'm not sure about the 45 degrees. I think the 30 degrees, 30 or 60 look better. So coincident with the top, coincident with the bottom, so it doesn't grow past the curve. And my preference is to loft. I have a little twist control with sweep I haven't quite resolved, so we'll select the midpoint, go to midpoint, and that goes pretty much corner to corner, so yeah, not really buying that one. So we'll go to 30 degrees. All right, so this needs a curve. And so this is the base of my curve, and we can either come up to features and go to curves. Not a split line, so we need to get out of that one. Make sure my line is selected. We're going to insert curve, make sure it shows up, and then this is going to be projected onto the face. And I probably should not have included the relief, because this just got more complicated. We'll see if it'll cut through the relief. That'll be interesting too. All right, so sketch on sketch combines, basically combines two curves, or the two sketches. So sketch on face, and it doesn't show me the preview going through both of those. So I'm kind of done before I started. Can I mirror those? That would be a little scary too, because that's a lot of geometry to mirror. All right, so did I include that in the base revolve? Of course I did. All right, let's see what kind of mess I can make of that. So really should have thought of the knurl early on, because at least one of these is going to, it didn't give me the error? Okay, now I'm a little upset that it didn't error. All right, so I'm going to have to go back after the fact and do a revolve cut for that relief. All right, so we have a curve going through the geometry. At the top, I'm going to create my diamond shape, and we'll go from outside to inside. All right, so am I going to get center? And then this is going to pierce. All right, I'm going to pick pierce over coincident because coincident could still be from here to here. Because in that plane, the projection of this curve in that plane is still, whatever, 60 degrees. Pierce says there's exactly one solution, and only one solution. Okay, so, oh, man, my mouse is having way more fun than I am. Okay, that that are going to be symmetrical. This can come back up and join in. Let's see, I'm not sure if it's 90 degrees, but oh, I picked up perpendicularity, so I don't need that one. I do want my midpoint to be coincident. Nope, nope, nope. Okay, now I'm just getting button happy. All right, we'll get that one in place. Okay, so we're normal too. Let's see what else can move. Oh, so we can stretch or shrink that way. No, I don't want an angle. I want a linear distance. So something else was selected. Let's make it a little bit smaller than that. So we'll go with the 3/16. And then let's see what that depth is. So 35 on the depth. Yes, that can be driven. All right. So that gives me one sketch. Control C. Control V. Puts a copy of that sketch. All right, so sketch 13. We're going to tie this back in largely the same way. Get back to where I can see the other end of the curve. And those become a pierce as well. That gave me fully defined. All right, so this is a curve-driven loft. It says that the two ends will remain to that face, and my diamonds will not kind of skew as I go across. All right, so top to bottom is lofted cut, and tendency is for it to go from angle to angle straight through. Guide curve is the curve that we created first and tied our geometry to. That gives it the twist. That gives me a nice little cut. We're going to turn on the temporary axes. And this is where we save, because if we're going to crash, this is going to crash it. All right, so the cut loft, the temporary axis, circular pattern, and we almost made it. 24 actually looks pretty good. How about 36? Okay, some nice even number. And what I'm looking for is each of these intersections, when I mirror this, it's going to have a diamond that is about the size of those two pieces, or the separation between those two pieces. So I almost want them to touch, but not fail. So 72 it is. Nice even angle, 360, half a degree. Keep my fingers crossed. You can do it. Fan didn't come on. All right. So there's the first gear. And then we go into, let's see, why don't we go, it's going to be front plane, cut loft, circular pattern. And if I mirror those, I should get the exact reverse. Keep my fingers crossed. Video card is working overtime. I know you can do it. 72 times 72 is however many little triangles times 4. We're asking a lot of my little laptop. So one of two outcomes. It's either going to look spectacular or be a total fail. So, and we can always try the geometry pattern, but I think we'll see what it does. I'm going to say I should pause the video and wait, but oh, it did something. So that's your knurl. Have a 35 thousandths raised, and it may not be a machined knurl, perfect machine knurl, but I have enough geometry there that when I 3D print this, I will be able to feel the texture. If I think about it, I'll grab the knurl that I printed and bring it in for Thursday. All right. So other considerations is this is going to be kind of sharp, even with fill material coming up to help this. Oh yeah, I guess I should save it at some point because we just like increased the size of this file by at least 10 times. We went from 100 and 150 kilobytes. It's at least 2 meg. Figuring out that geometry. All right, so the pattern, the mirror, the front, let's go ahead and show. And we'll go into the to the front, open up the sketch. Oh, maybe I needed the right. Nope, there it is. All right, so boy, it's going to be hard to see anything. So I need a revolve here, co-radial. I know I can see you in there, so I just have to find you. There we go. All right, so the little flat at the top, the knurls that we cut today actually had those. So I'm not as upset not bringing those to spikes. You know, you grab it and it, is painful to hold on to. But we could certainly go to like 84 and they would go to spikes. Probably go to spikes. It would also take another 5 minutes to rebuild. All right, so convert entities. Send this over to construction geometry since it's already there. I really don't like the intersection of this corner. So I don't want to pick up any of the loft geometry if I can help it, but I want to close off that corner. And struggling just a little bit on the response. Yep. All right, make sure I get these two, and if I make them equal, that'll be a 45 degree. And how about 060? Since we're on size, that should knock a decent amount off of the corner. And as much as I want to mirror that, I think I've done enough damage already, so we can set something equal here. Okay, so that did not quite make it. It made it to the edge. So that coincident has to go away. And that coincident. All right, so that object line, and that line are all equal, or not. Okay, so it's going to be that way. I either got other geometry, but we'll figure it out later. Oh, it picked up an inference somewhere. Coincident to whatever that point is. So that was the root of my my error. I really want to drive this off of one dimension though, so equal. All right, and then say goodbye to a third of it. Calculate that. Toroidal shape going through the middle, removing a third of our diamonds. Made it a little simple. The graphics card's not going to choke as quick. All right, and then all of that gets rolled forward. And hopefully no errors. And there we go. All right, so under the 3D print. Now this is also another good place for the configuration, not a display state. This is going to take a long time to load into the assembly, a long time to process. That being the case, I want to be able to suppress that as a configuration and say, maybe in the default, maybe in the 3D print this is there, maybe in my presentation mode it's there, and I will eat the time for it to calculate. When I'm just loading this into the assembly, the default doesn't have it, and so it will load much faster, not having to back calculate all of those triangles. So other than I need to now check my configuration, we got rid of those. Cut revolve is probably tied into, no, it's not actually. Good. Then let's unsuppress it. Don't know what that is. Oh, yeah, that was the first one that I can't type. But that has my geometry, so I can start to mix and match geometry. Let's see, that was the angle. Those are the temporary axes. So we can turn those off. We have the fine knurl as opposed to all of those diamonds. Right? When I'm ready to see the diamonds, either as the 3D print or as the presentation, turn those on, it gets rid of the holes, and we can switch between those suppressed, those different dimensions, and we're actually controlling the values of those parts. Right? Whereas the display state 3, is now tied to 3D print. If I set this to transparency for this configuration, could have picked a better one. Set it to red. Set it to blue or whatever. I think transparency going through all of those angles, that just kind of made me cringe. That we could go through and set the what it looks like and have that feel for what it's doing. All right, so enough time with this one. Questions? The loft and the sweep are another one of those advanced toughies. Yeah.
Probably more simplistic. I see how you're doing configurations and probably back and forth, but display state, was that automatically created?
Yes. So hidden down at the bottom of the configurations, you will have a display state. When you right-click on the display state, you have two choices, and then I always have to look for it. Is it underneath? We can remove all display states, add a display state, and then somewhere in here, let's double-click on it. We get a display state, properties, link display states to configurations. And if that is checked, then each new configuration gets its own display state. Typically, I will turn that off, and I will manage my display states by naming, and they will be globally available between the parts or in the assembly, whatever, between the features that I'm showing or hiding. It's especially useful in assemblies. Whereas I'm going through the process, wow, all this big bunch of sub-assemblies in my way, I can do a work in progress, or I can do a item removed type display state, and I don't have to create a specific configuration to do it. I can just say, this is my work in progress display state, and this whole sub-assembly is hidden. Do not show it to me. When I need it, I'll go back to display state 1, and then everything's available in the assembly. So we'll try and find a better lead into display states, but like I said before, is the display states are the visual properties. Is it in wireframe? Is it in solid? Hidden lines removed, hidden lines visible, transparency. I think I said. What color is it? What are all of those visual properties? Where configurations are driving dimensions, are driving suppression states. Does this exist or not exist? All right, it's all still there in the part. We created it. It's there, but it's not participating. So when I suppress something and it takes it out of that participation, It's still in the background. We're just not utilizing it at this moment. And let's see if I can find it. Nope, that wasn't the one I was looking for. Still not the one I'm looking for. Okay, I was gonna. How can we do that? I didn't want to navigate all the way to that folder. Find in my computer. Okay, so I missed it by a little bit. 10,967 kilobytes. It's 11 meg. That just got to be a huge file. We take 20 of those into an assembly. It's not so much that it's 11 meg, is there are 11 instances with that however many triangles times 11. So size-wise, we're not really accumulating 11 more meg each time we insert one into an assembly. We're creating the visual properties that come with all of that texture. That's what's going to suck down the resources in the computer. I'm a little freaked out about that right now. All right, looking at the cap is our last item. I'm not going to worry about the screw. The angles and the fill pattern again. I was kind of debating when I was thinking about this earlier. Would I print it in this orientation and allow the fill to come up the side and pretty much have the solid as an internal, or would I print it upside down and let the texture go this way and have the fill be internal? And I'm in that same situation where I'd like to delete this face, but all of these intersecting arcs and lines for that becomes problematic. I don't know that that's a pass. I think that's a fail. So if I'm going to go with fill material on these, I'm probably going to go with fill material on the internal and let it figure it out, because then the next step for the counterbore is I might as well go ahead and do fill material for it too, and just go ahead and print this in the convenient upside down. We have a good base for it to sit on, lots of contact. If we raft the fill material up to the part, we're gonna stay stuck to the geometry. All right, so as usual, took a little left turn, threw more configurations at you. I really the takeaway I want you to recognize for configurations is they have more uses than we can really get into. That you'll be able to kind of build out, and even at that base level of changing dimensions, and saying just for this configuration gives you a lot of horsepower. Taking it to that next level and configuring a feature takes it to that next level. Going into the Excel design table, wow. Exponentially more horsepower. But with that more horsepower comes more, you have to put the thought, you have to expend the energy to get that horsepower under control and get it working for you. Otherwise it gets to be a big ugly mess, and then things get tangled and go away. All right, so we're going to call that good, and I will take questions.